theorems. The remainder theorem, if your polynomial is divided by x minus c, the remainders are equals f of c. And your factor theorem has a factor of x minus c if and only if f of c equals 0. I expect that to make little to no sense to you, just reading it, that's okay. We're going to go through with long division and synthetic division today, and I'll show you how these theorems work, okay? How many of you guys remember synthetic division from last year? We like synthetic division, right? How many of you remember long division? Okay, so a little bit. That one's a little messier. We're going to try long division on these first couple of problems. These are simpler problems, and yes, you could do them with synthetic division, but we're going to practice long division on them just to make sure you get the process before I give you a longer, complicated long division problem. So when we set up our long division, my divisor goes on the outside, so the x plus 1, and then the 2x squared minus 3x minus 5, that goes on the inside for my division. You have to stay very neat and organized when you do long division. There's just too many places to mess up a sign or add or subtract wrong. And if you don't line things up nicely, it's just much easier to make those mistakes, okay? So first thing we're going to do, this x outside, right here. I want to know, what do I take this times to make it a 2x squared? 2x, right? Are we okay with that? So 2x goes up above. Doesn't matter where, just somewhere up here is 2x. Then I take this 2x times both the x and the 1. And I write those right under these two terms. So 2x times x is 2x squared. 2x times 1, I'm going to write plus 2x. All right, you guys remember, do we add or subtract in long division? Subtract, okay. So I'm going to put that in parentheses with a subtraction sign in front. All right, so 2x squared minus 2x squared, what is that going to be? 0. Okay, if that's ever not 0, you did something wrong and you should go back and try again, okay? All right, then the first place where something's pretty tough. I've got a negative 3x minus 2x. What is that? Negative 5x. Good. And I bring down minus 5. Remember so far? Okay. Then I start over. Now, what do I take x times again to make it negative 5x? All right, then we do our multiplying. So negative 5 times the x plus 1 will give me negative 5x minus 5. So what's negative 5x minus negative 5x? 0, good. What about negative 5 minus negative 5? 0, okay. That last number down there is your remainder, so I do not have a remainder this time. So this 2x minus 5, that's my answer. Okay. Questions? Did I lose anybody anywhere? You guys are going to try the next one. Do you notice anything about this one? There is no x squared. So what do we do about that? Yes, good. Put in 0x squared. So out front, I've got x minus 1. We have 2x cubed plus 0x squared minus 3x minus Okay, try that one. Talk to each other if you're stuck. I'll be walking around too, ask me questions. This one does have a remainder. So if you're not sure how to write the remainder, I can show you that in a second. Well.
I think so. Because when this comes out, yeah, our work is.
There and then you subtract. Just keep them together.
Okay. It's actually trying. They just said try your best. They just said try your best.
Which I get, I'll try your best. Yeah. I already got it over. So.
All right, guys, let me go through this one up here, and then I'm going to give you another one just to make sure we're okay with long division. Your brain. All right, most of you look like we're doing a really good job with the first step. We need a 2x squared. I multiply. And then please keep it neat, keep it organized, subtract. Minus and negative, guys, what does that become? Positive. Yeah, so this is positive 2x squared. Okay, and I saw a few of you that got here, and then you're like, great, now what? I don't know what to do. You just repeat that process with your new set of numbers down here. What do I take x times to get 2x squared? It's 2x. So I'm going to write up here plus 2x. Okay. I multiply again. So I'm going to get 2x squared minus 2x. Again, so many negatives. All right, 2x squared minus 2x squared, gone, we're good. What is negative 3x minus negative 2x? Negative 1x, yes, or just negative x, that's fine. Bring down minus 1. All right, how are we doing? Okay, what do I multiply by this time? Negative 1. So I will get negative x plus 1. Some of you got all the way here, and then subtraction gotcha. What is negative 4 minus 1? Negative 5. Okay, so that negative 5 is your remainder. There was a point where you would just write r negative 5. Okay, that's not how we're going to write our remainder anymore. You're always going to write plus, and then whatever your remainder is, so in this case negative 5, over your divisor. Now, for this one, technically, if you just wrote minus 5 over x minus 1, that's correct. When we get to remainders that have multiple terms, if you write a minus in front of the fraction, that's going to mess it up. So if you get in the habit of always plus and then whatever your remainder is over the divisor, it's just simpler, okay? So that is your answer for this one. How many got there? Yes, quite a few, okay. Getting there, getting close. All right, let's do another one, and this one is, oh, look at that. All right, try this guy. This is one that you could not do with synthetic division, okay? You can use your whiteboard, you can use the back of the front page of your packet. I don't care where you do this one. Just try this guy somewhere. UX.
Who else is doing that?
Yes, it always is getting those out. I don't. There's a better way to store them, unless you should just always put them in the desk behind you. I don't know. Guys, I'll write the remainder up here, because if you get the remainder right, it's very likely that you've got the entire thing right. So this is what you should end up with as the remainder, just as a check when you get to the end, okay? That's a special.
So, that's all.
So let's just erase this and resubtract.
Oh, because wait, but this times this times. Yeah, but and then it has to turn into negative. Hey. This is negative one, and that's turning into positive, so it's not bad. This is very big. Oh, you got -6, that's why. But then you can't have -6. This turns into a 6. Because 8 minus is. Yeah. That's why you got -6.
Wait, it is supposed to be negative.
So then you take your.
It is supposed to be negative. Now what?
You got the wrong thing.
No, because -4 times this is 4 times 2 is -8. And then if you have a negative on here, it's positive.
So I was right.
Yeah, which still means it's 6.
Yeah, I was right. No, not even when I was right. Everything that you was right. That's all it is.
Right here. What the?
What the hell? Okay, I did it right.
This right here.
Both
Negative
positive.
4x plus 2x is actually negative.
What's that?
One side. All right, guys, let me go through it up here. Okay.
How is it affected to it? Literally just added to
We're adding and subtracting skills, guys. It's, you know, the hard part, right? Okay, so I need a 3x squared, right? Okay. When I multiply by all three terms. So that's going to be plus 6x cubed minus 3x squared. Subtract. What is 2 minus 6? Negative 4. All right, we can do this, guys. Negative 4x cubed. Then we've got negative 1 minus negative 3. What does that end up being? Positive 2, right? And then bring down our 3x. Looked like most of you were okay to that step. And then the next one, we need a negative 4x up here. We got a lot of negatives going on now, and that's where things sort of became a struggle. Minus 8x squared plus 4x. Okay, those cancel. 2 minus negative 8 is positive 10x squared. And then guys, many of you had a 7 here. It is not 7x. 3 minus 4. Yeah, negative 1x. And then bring down plus 1. All right, last number we're multiplying by is 10. So I get 10x squared plus 20x minus 10. All right. Negative 1 minus 20 is negative 21x. And then I've got 1 minus negative 10, that's plus 11. So, plus negative 21x plus 11 all over x squared plus 2x minus 1. All right. Some of you made little mistakes along the way, but do you feel okay with the process? Like you get how to do it, it's just, you know, slow down, focus to get to the end. Okay, let's go back now and do some synthetic divisions. All right, guys, so back to your notes packet here. You all saw synthetic division. It is definitely a shortcut. It's a faster method, but it only works if what you're dividing by has a degree of 1. So see how we're dividing by x minus 2, x plus 1. I can't do synthetic division on the last problem we just did, okay? All right, if I'm dividing by x minus 2, what goes on the outside of my weird little half box here? Ooh, is it negative 2 or positive 2? It is positive 2. Is what would be like the solution, or what would make that divisor 0? So I'm going to do a 2. Then where do I get all the rest of my numbers from? Okay, just the coefficients off the top part, right? So 1, negative 3, 1, negative 4. This one's clearly just nicer. You don't have all the x's. All right, how do I start? Bring the 1 down. Good. Okay. What you've brought down, you multiply by the number outside. So I'm going to do 1 times 2, which is 2. And that lines up under the next number. Another reason we like synthetic division better is because you get to add instead of subtract. All right. So what is negative 3 plus 2? All right. What do I do with the negative 1? Get negative 2. Add. Negative 6. All right, your answer is not just those numbers, so we have to go back and put some variables with it. So think about what we're actually doing. We are taking an x cubed and dividing it by an x. So what would you expect to end up with? X squared, right? So your first term is an x squared. So that's 1x squared. I have to write the 1. Minus 1x minus 1. So what is the negative 6? The remainder. Good. So I'm going to say plus negative 6 over x minus 2. Okay. All right. Try 4 and 6 for me. We'll skip 5 just because I want to make sure we get everything. Okay. What do you need to be careful of on number 6? Yeah, see how it skips over x squared? Make sure you put a 0 in place.
Oh, yeah.
All right, let's go through these. I'll keep going here. All right, so I got a -1 on the outside. No remainder. 2x minus 5 is my answer for number 4. Yes, walking around, it looked like we were doing pretty well with these. Don't forget your 0 in this one. All right, so I'm going to get 2x squared plus 2x minus 1 plus -5 over x minus 1. All right, we good? Okay. All right, so on the back, we're going to start talking about the remainder theorem here. That's one of the theorems you had at the top of your notes. What the remainder theorem tells you about is if you plug in like whatever you would use for your synthetic division, you can quickly find the remainder. Okay, so we're going to just look at that with these two problems. So 7, if I went ahead and did synthetic division with that, I'd have a 2 on the outside, 1, -3, 1, -4. We're going to just go ahead and do the synthetic division. So I'll give you a minute to do that. And you don't have to rewrite it with the x's. You can just stop once you get to the remainder, okay? All right, what did we get as a remainder? -6. Okay. What the remainder theorem tells us is that if instead of doing synthetic division, if I took this 2 over here and I plugged it in everywhere there was an x in the numerator, which is what's written out over here. If I did 2 cubed minus 3 times 2 squared plus 2 minus 4. 8 minus 3 times 4 plus 2 minus 4. You would get -6. Okay, what is that the same number as? The remainder. Okay? Where this is going to matter is when we start trying to find factors of whatever we're dividing by. and you have a factor when the remainder is 0, so that's a quick way to check. I think synthetic division is faster most of the time than plugging it in. When you have the exponents and some larger numbers, sometimes, you know, it's not small and you guys won't have a calculator. So synthetic division is just a nice quick way to find that value. So let's look at what a question might look like. So number 9, it says find P of 5 using synthetic division. Okay, so P of 5, that's function notation from Algebra 2. You probably remember doing like, okay, I plug it in, right? Is the question asking you to plug it in? No, what is it asking you to do instead? Synthetic division. So what do you think goes on the outside of your synthetic division? 5, good. And then my 1, -3, 1, -4. Go ahead and go through your division. Did you guys get 51? Okay. Well, wait a second, make sure everybody's with us. So a lot of this is just making sure you know what the question is asking you to do, okay? If you wrote out the whole thing and told me x squared plus 2x plus 11 plus 51 over whatever divided by x minus 5, that's not what I'm asking for. I am only asking for the remainder, okay? All right. Okay, let's look at 10. It says factor completely using the given factor and long division. You don't have to do long division. We'll just say whatever division you want to do. If I'm dividing by x plus 2, could I do synthetic? Yes. Would we rather do synthetic?
Yes.
Yes. Okay. All right, so what goes on the outside for my synthetic? Good. And let's go ahead and divide. Get a remainder of 0. The video will be up on Blackboard this afternoon. Okay. All right. You can just zoom ahead video. All right. If they tell you it's a factor, you should absolutely get 0 as your remainder. That's what that means. If you don't get 0, I would go back and try again. Once you're here, then again, we've got to read our directions. It says factor completely. Well, so now I have this x squared minus 4x plus 3. Can I factor that?
Yes.
Yes. What does that factor into? Excellent. Now my answer, I'm factoring the original one completely. So I need one more factor in this. So what's the other factor? X plus 2, the one you're given. Don't neglect the one they give you, okay? That's the freebie. So that is your polynomial factored completely. Questions? Okay, all right, we've got one more. All right, use the remainder theorem to determine which binomial is a factor, and then use that binomial to factor completely. Okay, what does that mean? Which one has a remainder of 0? So you've got two choices here, x plus 5 and x minus 2. We're looking for the one that will give us a remainder of 0. So which one do you guys want to try? I heard 2. Is 2 a smaller number? I really don't remember which one works, so let's do 2. Do your synthetic division. Does it work? Yeah. So do I need to do anything with the x plus 5? No, we're going to ignore that. We found the one that works. So I now have 2x squared plus 3x plus 1. What else did the directions say to do? Factor completely. Okay, again, leading coefficient of 2. I don't care how you factor as long as you factor correctly. 2 is a prime number and 1 is a prime number, so there's, if you want to guess and check, this is as easy a guess and check as you can get. The only way to get 2x squared is 2x times x. The only way to get 1 is 1 times 1, and everything is positive. So those are my remaining factors. But again, if you do a box and it works for you, great. If you do grouping, great. As long as you can factor. All right, what is the other factor that I've forgotten? Good. In this one, we actually called this f of x, so I'll just say f of x equals, and then the factor form. Okay? All right, that's the end of notes, guys. Any questions? All right, homework is in your packet. All right, so if you look at the next page, it says homework standards 2. You're just dividing long and synthetic division. And then a little more of the find the value at the bottom. So synthetic division to find the remainder. And then find the rest of the factors of zeros. Okay? Makes sense? All right, so when do I see you guys next? Like, okay. So you've got plenty of time to get that done. Guys, you'll also get your first assessment back that day, so you can see how you're doing, start tracking your progress. And you will have, we're going to learn day 2 of standard 2, and then your next formative assessment. Okay, so just homework for next week.